First law basically talks about what is first law? How many of you? Conservation of energy is the first law. Okay. For example, H equal to E plus PV. This is what we call it as the first law. This is, let's say one way of calling the second law, if you want to say, and then we also have something called a third law of thermodynamics. How many of you are aware of third law? What is third law?
So every substance has zero entropy at 0 Kelvin.
Correct. So entropy S tends to 0 as T tends to 0. This is what is third law. This is what we say. Am I right? And there, one point that you all have to remember, whenever we say entropy, which is basically entropy is the degree of randomness in a material, and this degree of randomness can come into a material because of two important factors. One is called thermal, another is called configurational. For example, at any temperature there are vibrations inside a material, and these vibrations would cause some kind of randomness inside the material, and that particular randomness that you see is what is referred to as thermal entropy. And we define that particular entropy in terms of, how many of you know this? How is entropy defined? Yes, in fact, if you see the second law definition of entropy is ds equal to dh by t, or we can, it also comes out as q by t. Actually this is how the first at the beginning people have defined the entropy, and because we know under certain conditions, under what conditions q can be taken as dh? Constant pressure. So we take it as dh and it becomes dh by t. And H in principle, enthalpy is related to what? Internal energy. Okay, H equal to E plus PV we have already written, but how do you measure H? If somebody wants to calculate the enthalpy of a material, how does he? From the specific heat. So H is nothing but integral Cp dt from anywhere, from 0 let us say to some temperature T. So H is integral Cp dt, and basically Cp is what we know is a heat capacity of a material at constant pressure, and that is basically nothing but the amount of heat. How does one define the heat capacity? Tell me.
The amount of heat which a material can hold for a degree rise in temperature.
Correct. Not hold, the amount of heat that is required that it needs to raise the temperature. That is how we define. And once we define H as integral Cp dt, S automatically turns out to be, because ds is dh by t, so you can see that S is nothing but integral Cp dt by t. Okay. So these are the basic equations that one need to remember when we are talking about the entropy and the enthalpy, and in principle one can even find out how the entropy increases with the heat capacity. In fact, if you carefully observe this, the heat capacity of a material itself is not a constant term.